Okay, so imagine this. You're trying to run a supply chain, but it's the early 1800s. You've got all this stuff, tons of grain, lumber, you name it, stuck in the middle of America. And the only way to get it to the coast is on these dirt roads.
Dirt roads that are basically mud soup the second it starts to rain. It was a complete logistical nightmare.
Right. So how slow are we talking?
We're talking weeks, maybe a month, just to go a couple hundred miles with a heavy load. And the cost, I mean, sometimes the cost to ship the goods over the mountains was more than the goods themselves were even worth.
So if you're a farmer in, say, Ohio, your huge harvest is basically useless to anyone outside your local town.
Exactly. The whole economy was just stuck. And that led to this, well, this really radical idea. If the roads are useless and the rivers flow the wrong way, what do?
You build a new river?
You build a new river. An artificial waterway, a canal, designed for one thing, moving heavy stuff cheaply and efficiently. And that's what we're looking at today, how these man-made rivers got built, what powered them, and how they, completely changed America in just a few decades.
So let's start with the basics. What is a canal, really? It's not just a big ditch.
There's more to it than that.
A lot more. It's a precisely engineered channel of water. The whole point is to let boats travel where there's no natural river, often connecting two big bodies of water.
And the prep work? I mean, you can't just show up with a shovel.
Oh, no. Before anyone started digging, teams of surveyors had to map out the land for hundreds of miles. They're using these really basic tools to measure every little rise and fall on the ground.
Through forests, over rocks, all of it.
All of it. They had to clear the path first, which meant chopping down forests and blasting through rock. Then, and only then, could the digging start.
And even the digging was just brute force.
Completely. Thousands of workers with shovels and pickaxes. They dig the trench, and then they often had to line the sides with special clay and stone just to keep it from, collapsing or leaking.
All that work, and it really comes down to one simple idea, right? Friction.
It's all about friction.
Yeah.
On a road, a horse is fighting the rough ground every single step.
Yeah.
But in water...
there's almost no resistance.
Exactly. And that's the magic trick. A horse that could barely drag a ton on a wagon could suddenly pull a boat carrying 30, 40, even 50 times that weight.
And that's what made it all worth it, that efficiency. Okay, so when we talk about this, there's one project that's just iconic.
The Erie Canal. Has to be. In New York. Tell us about that one.
So this was the big one. Construction starts in 1817. The goal is to connect the Great Lakes all the way to the Hudson River, which leads right to New York City. We're talking 363 miles.
People thought it was a crazy idea at the time.
Oh, totally. They called it Clinton's Big Ditch after the governor who pushed for it. They thought it would bankrupt the state. A huge, foolish waste of money.
You can kind of see why they were skeptical. You can. The route went through swamps, like the Montezuma Marsh, where workers got sick and the ground was constantly sinking. They had to build these huge stone aqueducts.
Like a bridge for water.
Exactly. A water bridge to carry the canal over other rivers. I mean, it's an incredible feat of engineering for the time.
And it was all done with muscle and animal power.
And when it finally opened in 1825, all those critics went quiet. A massive, immediate success. And that success just sparked this canal-building craze everywhere else.
But there's a big problem they had to solve first. Water likes to be flat.
It does.
New York State isn't flat. It rises more than 500 feet between the Hudson and Lake Erie. So how do you get a boat to go uphill?
That is the million-dollar question. And the answer is the lock system. It's pure genius.
Okay, so break that down for us. What's a lock?
Think of it like a water elevator for boats. It's a big stone chamber built right into the canal. If a boat needs to go up, it floats into the lock. These huge wooden gates close behind it. And then water from the higher level floods in.
And just lifts the boat up.
Gently lifts it up to the next level. To go down, you do the opposite. The boat goes in, the gates close, and they drain the water out, lowering the boat.
Oh.
It was incredibly precise work. The Erie Canal needed 83 of these things to make that 363-mile journey possible. Without locks, canals only work on perfectly flat land.
So let's talk about the engine, the thing that actually made the boats move.
The humble draft animal, horses, and especially mules.
Mules. They were the real workhorses, so to speak.
They really were. They would walk along a path right next to the canal. It was called the towpath. A long rope connected their harness to the boat, and they just walked.
And the amount of weight they could pull is what's so amazing.
It is. Just because of that low friction in the water, a couple of mules could pull a boat weighing 30 tons or more with no problem.
So you needed a whole support system just for the animals.
Absolutely. The canal was hundreds of miles long. So they built stables every few miles along the towpath. A team of mules would pull for a stretch, then they get swapped out for a fresh team to rest and eat. It was a whole ecosystem built around keeping these animals working.
What was it like to actually be on one of those boats? I'm guessing it wasn't a speedboat.
No, definitely not. The boats had to be long and narrow so they could fit inside the locks, and your top speed was, the walking pace of a mule, about 4 miles an hour.
So slow.
Very slow. But for passengers, that was actually a good thing. They had special passenger boats called packets.
And this was better than a stagecoach.
Oh, way better. A stagecoach was bumpy, loud, just miserable. The canal boat was a smooth, gentle glide. You could actually relax. And a lot of the families who worked the boats lived right on them. The kids would help with the animals or steering. It was like this unique floating community all moving together.
But the main point of all this wasn't passenger travel. It was about moving goods.
It was pure commerce. The canals became America's first real supply chain for heavy stuff. All that wheat and corn that farmers were growing in the Midwest finally had a cheap way to get to the big cities on the East Coast.
And that changed everything for the price of food.
It did. Before the Erie Canal, shipping a barrel of flour from Buffalo to New York City might cost, in today's money, almost $100.
Wow.
After the canal, that cost dropped by about 90%.
90%? That's incredible.
It is. And that didn't just help farmers. Cheaper food meant city workers had more money to spend on other things, which helped factories grow. It's really what made New York City the economic powerhouse it became.
And this conveyor belt, as you called it, ran both ways.
It had to. The boats didn't go back west empty. They were loaded up with manufactured goods.
Like what kind of stuff?
Iron tools, furniture, clothes, books, paper. Things that were once expensive luxuries for a family on the frontier.
And now they were affordable.
Exactly. It made life better out west and connected the country's economy in a way that had never been possible before.
And you could actually see this change happening on the ground. Little villages along the canal routes just exploded.
They boomed overnight. Suddenly, they were major hubs of commerce. You had warehouses, hotels, blacksmiths, taverns. Land values went through the roof. It created entire new towns and thousands of jobs.
So beyond just economics, the canals also changed who was living where. They were a huge driver for migration.
A massive driver. It was the first really safe and comfortable way for a whole family to move west. You could load all your possessions onto a canal boat, your furniture, your tools, everything. You just couldn't do that in a wagon over the mountains.
So it opened the floodgates.
It really did. The population around the Great Lakes just exploded. New communities were established in Michigan, Illinois, Wisconsin. The canals were basically the gateway to the West for a whole generation.
So if they were this revolutionary, why aren't they still everywhere? What happened?
Well, their biggest strength was also their biggest weakness. They were slow. A mule walking at 4 miles an hour was amazing for its time, but technology was about to take a huge leap forward.
And they had other problems, too.
Big ones. They needed a lot of water, so you could only build them in certain places, and maybe most importantly, in the north, they would freeze solid for months in the winter.
Shutting down all trade.
Completely. And then came the steam locomotive, the railroad.
The Iron Horse.
The Iron Horse. And it changed everything. Trains were so much faster they could go almost anywhere, and they ran year-round, rain or shine or snow.
And businesses followed the speed and reliability.
Instantly. The money and the freight just shifted from the canals to the rails. A lot of canals started losing money and were just abandoned.
So what's their legacy today? Are they just gone?
Not entirely. Their impact is still with us. A lot of old towpaths are now scenic hiking trails or even modern highways, and you can still see the old stone locks and aqueducts in places. They're these beautiful monuments to this incredible era of engineering.
It's amazing. In just a couple of decades, they proved you could overcome huge physical barriers like mountains and link the entire country into a single, powerful economy.
It really shows you that how we move things, our infrastructure, fundamentally shapes the world we live in.
See you next time.